Dimensional analysis. Dimensional analysis is a complicated sounding term for a straightforward idea. It just means keeping track of your units and performing unit conversions wherever you find you need them. As an example, let's use Newton's equation for the gravitational force F between two objects and verify that the units work out correctly. Here, force is given in units called newtons, yes, named after Isaac Newton, and abbreviated N. Newton's equation says that the force between two objects is determined by multiplying the mass of one object by the mass of a second object and dividing by the distance between them squared. And all this is times a gravitational constant, g. If we use the Sun and Earth as the two objects, we can use this equation to find the gravitational force between them. We can look up the gravitational constant, the two masses, and the distance between them to plug in values for this equation. Since the units of force are newtons, that is what we want to end up with after combining all the units on the right-hand side of the equation. For clarity, let's isolate these units from the numerical part so we can evaluate them separately. The numerical part can be solved on your calculator, but let's look more carefully at the units. We have Newton meter squared kilogram squared divided by kilogram squared kilometer squared. The kilogram squared in the numerator and denominator cancel, but notice that the gravitational constant includes the units of meters squared in the numerator, while in the denominator, distance, which was squared, has the units of kilometers squared. This means we need to use unit conversions. There are 1,000 meters in a kilometer, so you need to multiply your numerical answer by 1 kilometer per 1,000 meters twice because these distance units are squared. Then all the units will cancel except for the N, newtons, which is what you wanted. Finally, after dividing the numerical part of your answer by those two factors of 1,000, you are left with a force equal to 3.52 times 10 to the 22 newtons. By carefully looking at the units, you found that you needed additional unit conversions to arrive at this correct answer.